friends, till now we have discussed that in case of laser light amplifications takes place, right? In the last class we have seen the requirements to get this amplification. Today we will see how to achieve this light amplification in case of a laser. Coming to our last class discussion, we have seen that the requirements for amplification are the incident energy density should be high. The second one is that longer lifetime at excited state, and the third one is population inversion. These are the requirements for amplification of light in case of laser. Now, how to achieve these conditions? The first condition we need to satisfy is that the incident energy density should be high. So to make this energy density high, we are using a arrangement which is known as resonant or optical cavity. What is this resonant cavity or optical cavity? This is a special arrangement where photons are bounced back and forth to enhance the light intensity, because the first condition is that the intensity of light should be high. So this we can obtain by increasing the number of photons, and the arrangement through which we are increasing the number of photons, that is known as resonant cavity or optical cavity. Basically, this is made up of two parallel reflecting surfaces. For example, I can take two mirrors. So these are two parallel surfaces or mirrors which will act like an optical cavity or resonant cavity. This shape may be also like this, okay? Inside this, actually we are having this active medium or lasing medium, okay? So that is kept in between these two parallel reflecting surfaces. So now when photons are moving through this active medium and hitting these two reflecting surfaces, let us see what is happening. So this is a photon. If it will move from here, when this will hit this mirror, it will bounce back from here and it will start moving towards the first one. Okay, so while these photons are moving through this active medium, they will hit the atoms in the excited state. Okay, that will lead to stimulated emissions, and we know that the stimulated emissions are the process through which the photons will get multiplied. Okay, so as they are moving here to this mirror and again from this place to this place, so number of times they are moving within these two plates, and we are getting number of stimulated emissions, and hence the number of photons are getting multiplied, which increases the light intensity, right? Further, one of these two mirrors or both the mirrors, they are partially transmitting in nature. Either one is made, here I have shown that this one face is made partially transmitting in nature. But in some cases, both the mirrors will also be partially transmitting in nature. So, as this is partially transmitting in nature, few of the photons, they will come out through this mirror, and this is nothing but our output of the laser. So one or both of these surfaces are partially transmitting in nature, through which fraction of light leaks out as output of the laser. So whatever light is coming out through this mirror, that is the output of the laser. Thus, through this arrangement, we are increasing the intensity of light, which is our first condition for light amplification. Now coming to the second one, that is population inversion, right? So what is the meaning of population inversion? Here I have shown you the ground state E1 and an excited state E2. So under normal equilibrium condition, what happens? These are the number of atoms at the ground state, and number of atoms in the excited state is very few as compared to the number of atoms in the ground state. So this is our normal equilibrium condition. Most of the atoms will found them in the ground state, very few are there in the excited state. That means at thermal equilibrium condition, N2 is less than N1. N2 is the number of atoms at the excited state and N1 is the number of atoms in the ground state. So at thermal equilibrium condition, N2 should always be less than N1. This is also known as normal state. Now if some or other means some of these atoms they get the energy which is equals to the difference between these two levels, then they will move to the excited state. Once they start moving here, and if we are getting more number of atoms at the excited state as compared to the number of atoms in the ground state, then that is known as population inversion. So in that case we are having more number of atoms at the excited state and less number of atoms at the ground state. That means N2 is greater than N1, but this is not an equilibrium condition, okay, because we are giving some energy to move these atoms to the excited state, okay. So this is non-equilibrium condition. This is also known as inverted state. In normal state we are having more number of atoms in the ground state, but in case of inverted state, that is just the opposite, we are getting more number of atoms in the excited state. So population inversion is the situation where more number of atoms are there in the excited state as compared to the lower energy state or ground state. So this is the condition for population inversion. We should have more number of atoms at the excited state compared to the lower energy state or ground state, right? Now as I have told that these atoms they cannot move by their own from this state to this state. They have to get some energy from some external source. Thus to achieve population inversion we need to supply energy to the laser medium. If we will supply energy, then only these atoms they will get some energy, and if that energy is equals to the difference between these two levels, then they will move to the excited state. And the method through which we are supplying this energy, that method is or that process is known as pumping, okay. There are different types of pumpings. Optical pumping, where light radiation is used for pumping the atoms or electrons depending on the system, okay. Electrical pumping, in which accelerated electrons are used to give that radiation or energy. In chemical pumping, chemical reactions are used to give the energy. Further, thermal pumping is the process in which heat radiation is used for pumping mechanism. And as we have already discussed, in case of semiconductor laser or laser diode, direct conversion of electrical energy into light energy takes place. So these are few of the pumping methods. Now let us move to the next one, that is a higher lifetime at the or a larger lifetime in the excited state, right? Till now we have seen that to get the lasing action, population inversion is must, right? So population inversion is must means, like this is a situation, these are the atoms at the ground state. When we can say that there is population inversion, if more than 50% of these atoms they move to the higher energy state, then only the number of atoms in the excited state will be more than the number of atoms in the ground state, and we can say that population inversion took place, right? But in case of normal materials, what happens when these atoms they move to the excited state, they'll stay here for a very small amount of time, that is of the order of nanosecond, okay, or 10 to the power minus 9 second. So this is the order of time for which the excited atoms will stay at the excited state, okay. Let one photon is coming and hitting this atom. So by observing this photon, this atom will move to the excited state. This atom is moving to the excited state. Now suppose another photon is coming and observing this photon, this atom will move to the excited state. But they cannot stay here more than 10 to the power 9 minus 9 second. So within some nanosecond time, they will come back to the ground state, okay. So by the time some of these atoms they are moving to the excited state, the atoms which have moved earlier, they will come back to the ground state. So in that case what happens, it is the probability is very less that we will be getting more than 50% of atoms in the excited state, okay. Thus it is very difficult for a two-level system to achieve population inversion, and if there is no population inversion, then lasing action will not take place, right, because that is one of the requirement. So two-level systems are not suitable for lasing action, because in this case we have seen that the lifetime of atoms in the excited state is very less, and hence it is very difficult to get more than half of the atoms to be in the excited state. So here what we have seen, that for lasing action we need population inversion, that is N2 should be greater than N1. But in this two-level system, to achieve this condition it is very difficult, okay. So what is the solution for this? The solution is that introduction of metastable states. What is this metastable state? These are some of the excited states which are introduced into the system by applying some impurities or some other means. So these metastable states are excited state which are lying between these two energy states E1 and E2. Further, the lifetime of the atoms at the metastable state is quite large as compared to the lifetime of the atoms in this excited state. This is roughly of the order of 10 to the power minus 6 second, whereas in this excited state it is 10 to the power minus 9 second. So metastable states are excited states with relatively long lifetime compared to other excited states, and these are introduced between these two energy states. Generally we are calling this as ground state. This is the pumping state or pumping level. From here we are pumping the atoms to the pumping level, and in between these two levels we are having some excited states which are having relatively long lifetime as compared to this pumping state, okay. So these metastable states are required to achieve population inversion, and hence systems with metastable states are suitable for lasing action. If the system is having only these two levels, then it is very difficult to get population inversion, and those materials are not suitable for lasing action. But the materials which are having metastable states in between these two levels, in those materials we can achieve population inversion, and hence those materials are suitable for lasing axon. Now we can have either one metastable state in between E1 and E2, or else we can also have two metastable states. Okay, so let us see what is that. So if this is E1 and E2, E1 is the lower energy level or the ground state, and this is the higher energy state or pumping state, right? So this is E2 is the pump state. If we are having one metastable state in between these two states, that is known as a 3-level laser system, and ruby laser is an example of 3-level laser system. Basically, this is called 3-level laser systems because in the process of lasing, we are having 3 energy levels which are involved for the lasing action. Here, the lifetime of the atoms at this state is very large as compared to the lifetime at this excited state, and hence this black one is known as metastable state. Coming to another situation, these are the two states. One is the ground level and this is the pump state. But the difference is that in this case we are having two states in between E1 and E2. Okay. So finally we are getting 1, 2, 3 and 4 energy levels which are involved for the lasing process, right? So this is known as 4-level laser system, and helium neon laser is an example for 4-level laser system. So here these two are known as metastable states. Okay. Here I have written E1, E2, but in our further discussion I can take this as E1, this as E2 and this as E3 in chronological order. Similarly, for 4-level system, I will use this as E1, this as E2, this as E3 and this is E4. Okay. So, in our further discussion, we will be using these notations. After knowing that there are 3-level and 4-level laser systems, you must be thinking that how lasing occurs in 3-level and 4-level systems. Further, what are the differences between these two, and is there any difference in their outputs? So all these questions must be wandering inside your mind. I shall be coming with the answer to these questions in the next video. Today we'll stop here. If you like the content of the video, please press the like button and share the link with your friends. Further, do subscribe to my channel to get the notifications whenever I am uploading a new video. Thank you all.